A very good afternoon, everyone. A warm welcome to all the participants joining us today. On behalf of Capgemini, GNI, and the Computer Society of India, it's my pleasure to welcome you to this insightful webinar on data streaming using AWS Stack. In today's digital world, data is no longer just stored and analyzed after the fact. Instead, it's streamed live, processed in motion, and acted upon real time, whether it's monitoring millions of IoT devices, analyzing financial transactions as they happen, or detecting security threats instantly. Real-time data streaming is transforming industries. And when it comes to building powerful, scalable, and secure streaming architectures, AWS offers one of the most robust and flexible stacks in the market. From Amazon Kinesis and AWS Lambda to Amazon MSK, managed streaming for Apache Kafka, and Glue on Redshift for downstream analytics, AWS enables organizations to build end-to-end streaming data pipelines that are cost-effective, resilient, and production-ready. The webinar will explore how to ingest massive volumes of live data, process and analyze it in real time, store and visualize it for the downstream intelligence, and ensure the entire pipeline is secure, scalable, and highly available. We will break down key AWS services, design patterns, use cases, and even architectural best practices to help you move from batch processing to real-time streaming. Whether you are a cloud architect, data engineer, or a business leader curious about real-time insights, this session is designed to equip you with both technical depth and strategic clarity. So get ready to explore how AWS can power next-generation data applications, streamed processed
Hello.
at the streamed speed business. We are privileged to have an excellent speaker, Jaydeep with us today to take us through topic. Now I invite Ms. Rajashree Sutravi from CSI Department, GuruNanak Institution's Technical Campus to introduce our today's speaker.
Ma'am, you're on mute.
Good afternoon to one and all. It gives me great pleasure to introduce Jaydeep, our esteemed speaker for today's webinar on data streaming using AWS Stack. With over 22 years of industry experience, Jaydeep brings a depth of expertise in building real-time streaming architectures at scale. As a technical architect at Capgemini, he has hands-on experience leveraging AWS, MSK, Kinesis, Glue, PySpark to design and operate robust streaming pipelines that span cross-account, cross-region boundaries. In his recently published article, AWS MSK to process streaming data, Jaydeep walked us through a real-world AWS implementation using SQS FIFO, AWS Glue, schema validation, and Kafka topics for streaming IoT data across AWS accounts efficiently and securely. His technical acumen isn't solo. Jaydeep regularly shares insights on broader AI and data topics like agentic AI and real-time observability pipelines built on AWS. With his deep AWS background and thought leadership, Jaydeep is ideally suited to lead us through how to architect, scale, and optimize data streaming workflows that deliver low latency processing, high throughput, and actionable insights. Today, he will share practical design patterns, lessons learned, and best practices for leveraging the full AWS streaming stack from Kinesis data streams and MSK through Glue ETL to streaming ingestion into Redshift or S3. Get ready to gain real-world knowledge and inspiration on how to Ladies and gentlemen, please join me in welcoming Jaydeep Pal sir. Please post your questions in chat. He will answer them all. Over to you, Jaydeep Pal sir.
Thank you, madam. First of all, I would like to thank Computer Society of India to give me an opportunity to talk to such a talented folks. Like, it's very rare and it's a privilege to me. I'm honored for that. And thanks again for the GuruNanak University for getting together to, find what's happening in this ever challenging data world. Data is nowadays, data is called the fuel for the future. So all the decisions we make, all things we do it by analyzing our data and our insight. Let me share my screen and let me check whether my screen is visible to you or not. And as madam said, please feel free to type in this chat, and we'll have some 15 minutes Q&A session where I would like to answer most of your queries if time permits. Otherwise, you are welcome to send me an email. I'll try to, answer your queries offline. So today's agenda, we'll go through it, like what are the native AWS services we can use, we can leverage, and we'll see that like how what is Kafka and how AWS has integrated Kafka in their framework, and we'll have a couple of slides describing the Kafka architecture. Then we'll jump to a very generic solution, which is very simplified, and I don't want to make it complex so that it can be easily understood. And then how we can ingest data to Kafka, and a simple real world example where streaming data is used. So feel free to type your question anytime in the chat, and I'll try to answer all your queries. Let me go to presentation mode. Hope my screen is visible. So here, sorry. Here we are using various AWS tools and technologies. My screen is visible. I think,
Yes.
yeah. So this Amazon MSK, it is in the heart of this architecture. We will spend a few moments while explaining the Kafka architecture, and then we have Amazon Redshift. Like it is used for structured data storage. Say for example, you store your database in PostgreSQL, Postgres, or Oracle, or DB. So Amazon has provided this RDS capability where you can store your data in any of these databases, and using JDBC connector, you can connect to these databases. Now, there is something like AWS Glue. What is Glue? Glue is a computing engine. It is serverless, and it has some. You can think of Glue is a CPU kind of thing. It can do. Right? I think you have heard of. It is not ITL. It is ETL. I'm sorry for this typo. So extract, transform, load, or extract, load, and transform. Those are the buzzwords nowadays. So Glue can be used in this thing. And then you can see that Amazon S3. What is S3? It is a standard storage type provided by Amazon, and it is very cheap. I mean, and the cheapest out of all the storage, that is Amazon S3. And there you have Amazon SNS for error messages. Like not error message. If anything, you need to be notified. Say for example, uh, you have switched on the AC, and the temperature goes beyond 30 degrees in your room, then you can get a notification using SNS. And Amazon Redshift, it's kind of a data warehouse. So yes, please try to type your questions in the chat so that I'll answer you shortly. So Amazon Redshift is the widely used data warehouse. Like you must have heard the what is data warehouse and what is database, and I'm not going to explain you everything. So, and Amazon DynamoDB is one kind of database, like, like currently everybody is out of RDBMS, right? Parent key, foreign key relationship, and all these things. And all the databases are, structured. We expect all the data should be structured and should fit into tables. But nowadays we deal with the real challenge is that, like, sometimes we do not have any, 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 any control over the data. So we have developed kind of a unstructured database. Say, for example, you have a software, like, and you need to give the name of the family member. So a couple comes and they say that they have one child and his name is this and his age is that. Now another couple comes and they say they have two children, child one with this description and child two another description. So how do you fit into it? Then Amazon DynamoDB, kind of, you might have heard MongoDB, that's, or in big data world that there is HBase. So this kind of, unstructured data we need to deal with. So we can, we have introduced several unstructured databases, and AWS provides DynamoDB. It is very fast and reliable. And Amazon OpenSearch, like, we can use it to, and get the insight of the real-time data. We can monitor the data quality of it. And like here, the last but not the least is the REST API. In AWS, everything is API, and the connectors are very important. If you want to connect one service to another service, you need to have a compatible connector. Now I'm going to, deal with the Kafka. So, this Kafka, like, everybody, I think, have heard of LinkedIn. So, LinkedIn first invented Kafka, and later it has become, open source, and it is called Apache Kafka. So, what is that? Like, here you can see it is used for streaming data. Okay, with the almost no latency and no downtime. They provide a robust architecture to handle streaming data. So here you can see these are the producers. These are nothing but clients, and these are the consumers. And what is Kafka cluster? You can say that in layman's term, it's a server. But in Kafka, it is said it is broker. That is the terminology. It starts with something like B slash something like that. And there is something called topic. You can see that these are the topics. So each topic again divided into multiple partitions. So what is that? Like, it is for, like, say, for example, this producer, it is linked with this topic, first topic and the third topic. So it will be able to send data from the client to topic one and topic three. And this one said it can send data for both the topics. Now comes with the partition. So what is partition? In the topic, we can have every message is tagged with some offset value, and the partition is something like the more granular level of the topic. You can see each of the topic has three partitions. Don't think that three is fixed. You can have as many partitions as you wish, depending upon your hardware. So, and in the next slide, you'll see that what is fault tolerance. Like, see, there are three brokers. One broker is the leader, and the others are updated at the same time. So if one broker goes down, the other will come up and serve your purpose in order to minimize the downtime. You don't have to do anything. That is the Apache Kafka. And in the next slide, you can see that what I have told you, right? These are the producers, and you can see there are some replicas. So if this is not available, partition one, you can have the replica partition one in here, and you can take the data and you can consume the data. And what is Zookeeper? Nowadays, Zookeeper is not used. I'll come to that when I will describe MSK. So Zookeeper is the health checker. Like, it checks the health of the servers. Like, if anything goes down, it triggers the next thing and to make another server available for that. So all the things are developed by Apache Kafka, but what Amazon provides, Amazon says, okay, you don't have to worry about these hardwares like these zookeepers and all these things. You don't have to worry about it. We have developed our software. It is called SaaS, that is software as a service. You purchase it and you just need to worry about your application, not about how to maintain your hardware. So it is called managed service for Kafka. That is brief about Apache Kafka. Hope because if I go on, then it should take some most of the time, it needs one day session like to cover the whole thing Kafka. Now, anyway, like I'll tell you a couple of things. Say, for example, um, you can see that these are the data. You can say A, B, C, D, something like that. Say in one point of time, something goes down. Like say this topic is sending data to, uh, in MySQL database. Now the JDBC connector that goes down. Then what will happen? Will the data be lost? Or say, for example, some problem happens with the servers all at a time, or there is a bug in the application which disrupts the system. Then what will happen? It is streaming data, right? And Kafka goes down. Then how can you recover this thing? So there is a concept of offset and checkpoint location. So the thing is that like when Kafka is working, I from now onwards I will say MSK, not Apache Kafka. MSK, we are free. We don't have to think about the hardware, and because it is managed by AWS. Yes, please. Yes, please. Somebody is saying something. Okay, let me resume. Say there is a checkpoint location. We generally store it in S3. Okay, in this S3, uh, the the last updated offset. You can see that A is having offsets as 0, B1, C2, D3, and E4. Now, after consuming E, the fourth offset that is stored in S3 bucket. Okay. Now something goes, this Kafka, this whole thing has been messed up. Then next time when you resume your service, it will start reading from after E. Kafka automatically manages the fault recovery. That is the beauty of Kafka. Your data will not be lost. Now, there is a concept of, retention period. In general, MSK provides 7 days retention period. So today is 6th, right? So you can recover data till 1st of this month, or even you can go earlier. Like it manages 24 into 7 hours data in its topic. But as it is costly, we generally do not do it because 7 days is huge, right? We don't want to, waste our money here. So with the help of offset and the checkpoint location, uh, you can retrieve the data. Sometimes it may so happen, say you have designed a program and it is say for example, up your calculation, there is a bug in your arithmetic calculation, say for what is the revenue of a particular bank. Okay, you do some wrong calculation and you need to reprocess this thing. There is a concept of earliest. Like when you are saying that offset, you can send a parameter earliest, so that it will again start from the first message itself. And if you don't want to bother about whatever already has been consumed, you can give the offset is latest. Then what is the latest message? It starts consuming from the latest message. And there is another parameter called shift. Like you can go, like if you give -2, it will shift from E to D and all these things. Those things are natively provided by MSK as well as Apache Kafka. Okay, so now this is about producer. A producer can be Lambda and a consumer can be your ETL process kind of thing. So now we can ask why MSK? Like Amazon gives, just like all the major vendors, it gives other ingestion technologies like Firehose, Amazon Kinesis Firehose or KDS. So those are some of the things. But in this seminar, we will discuss about only MSK. I'm not going into the other other streaming data services like Flink, Apache Flink, or Flink is also, taken by AWS, and you can have the streaming data in Flink. But there is a restriction. Flink will stop supporting Python in near future, so it supports Java or Scala. Now, like Python, like what I request everyone to be familiar with Python at least, because Python, PySpark, those are the integral part, like those have become the bread and butter of all the software developers. It is very easy to learn and it's very robust. Okay, so broadly we can call it a producer. These are the servers and these are the consumers. The consumer can subscribe to particular topic and it can consume the messages from those topics. And now what happens? There might be duplication of message, right? Say this consumer, it has subscribed to this topic A, and it is consuming data from partition 1, and again this A, it starts. If there is an error from here to here, it start here also. Then you are consuming duplicate message, right? Then there is a problem, right? And if you don't allow the consumers fetch message parallelly, then you are losing the latency. It will work as a sequential process, and it is just analogous to your batch process. So we need to have the parallel processing, parallel consumption of data using MSK or Apache Kafka. Now, in order to avoid the duplication, there is a concept called consumer group. The consumers are belonging to some particular consumer group, and that group checks there should not be any duplication. Consumer, you can say that for the time being, because it needs some time actually to explain everything. So consumer group, you can think of for the time being, is responsible for avoiding duplication of the consumed messages. Fine. And zookeeper, like node 1, node 2, node 3, like those who knows a little bit of big data, you can say that those are name nodes. Like name node is the brain of any big data architecture. And if one name node goes down, the secondary name node comes into play in order to avoid the system crash. Okay, next is, see here, it's a very simple diagram. You can add as respected madam like told that GNAI comes into the AI comes into picture and all these things. Say for example, right? Earlier, what like though you are teenagers, I believe, so you cannot think of the old days like when we used to stand in a queue of a bank in order to withdraw money, and then we need to update our passbook. All these things happen. Now you go to an ATM, insert your card, withdraw money, and instantly you get an SMS in your mobile. That is the beauty of real time. You don't have to wait for the entire day or entire month, something like that. Those are called batch, and these are the real time processing provided by MSK, Kafka. It is the logo of MSK. Now, there is a concept of near real time. Say, for example, you are doing something and you don't. One thing you need to be aware of when you are planning to consume data real time, that means you are using multiple APIs called at the same time, and that is costly. Sometimes as an architect, when you'll be playing a role of a data engineer or a data architect, you need to be, also aware about what is the cost. Your client will come to you and ask you, hey, you have designed this thing, this is very wonderful, but it costs this much dollar, which I cannot afford. Then you can say, okay, so I can make it near real time. So the dashboard, what you are watching, monitoring your system health or any issues, that will be refreshed in every 5 seconds. Then this 5 second, what is that? This is nothing but micro batch. You are processing your request as batch, but the but the batch window is 5 seconds only. So in every 5 seconds, you are issuing only one single API, which interacts with the entire system and which will solve your problem. So if you can get back to your client saying that, hey, I can do it. I can minimize the cost by half, 50%. If you allow me, the refresh rate of your system would be 5 seconds. Do you mind? If he says no, then obviously you can go for near real time. And real time is that, say you are watching a cricket match. You guys, like, Virat Kohli is batting and he hits a six or somebody gets out. You don't have to wait for the 5 seconds to to get the latest update. Then you need real time application. So every second, every microsecond or every microsecond, you have the insight. You have heard of that nowadays, the countries, they are building their weapons, radar system, a fighter jet, all are nothing but real time things. So nowadays, either a living being or a non-living being, they always, radiates electronic signature. You are carrying your mobile, and in WhatsApp you share your location, and you share it with me, and you say I'm traveling from city 1 to city 2, and this is my live location. I can real time, I can track you where you are moving. So everything, like if a fighter jet comes, the radar will automatically understand by the electromagnetic wave it radiates and it can easily lock it. So that is real time. Now, uh, here, if you see that, it is a general solution. It can be fit to any of the application depending upon your um, requirements. So here is the Kafka topic. Kafka topic, like say, it can be in the next slide. I will go for some ingestion technique. Most of you are aware of that Lambda. Like say you are running a factory, you are running a machinery, and the cooling is needed in order to have the optimal work delivered by the machine. Say, for example, the temperature should not go beyond 3 degrees Celsius. Then you can have a sensor, you can have the lambda. If it detects, okay, this is something it needs immediate attention because temperature is above 3 degrees centigrade. Then the lambda kicks out and it sends data to MSK topic. And Glue, you can consume the data. You can think of Glue is a consumer. And ETL transform, it does the thing. And here in Glue, you can have some SNS, I have mentioned that notification service, and some other things. Now, Glue, if you go to AWS console, it is free, like free tier is there, right? I think everybody should open a free tier account and you can experiment with Glue and all these things. So Glue has something like called DPU, data processing unit. It can be 2, and I don't know how much you can increase it, 10, 20, 30, depending upon your budget. And in Glue, there is one thing that is called Glue catalog. What I have written, Glue schema registry. Fine. What is that? Like, as I have mentioned, like, like you may have heard of JSON data. Uh, JSON is a semi-structured data. Say it may have, it is nothing but a key value pair. Say name, colon, then say Philip. So name is key and value is Philip. So age something like 48, something like that. So for example, your MSK topic, if this Glue consumes data from MSK topic, I'm going to the previous slide. So here the consumers is Glue and it is detecting data, getting data. And there it is checking with some, say there are 10 different kind of tables, like something is made for RDS, something Redshift, something DynamoDB, something other things. So it talks to this Glue schema registry or Glue data catalog. What is the metadata of the table? Say erroneously a table has 5 fields. Uh, Sorry. Okay. So I'm not able to hear you. Okay, I'll take it later. Like I'll quickly go another. Give me a 5 to 10 minutes, and I'll complete it. Then I'll come back to you. So this is holding the schema of the say 10 tables, which is expected. Say instead of 10 fields in your JSON data, 10 keys, it comes 8 or 12. Then what the glue will do? Glue will notify that hey, something is going wrong. It is not matching with the predefined registry. So it sends an SNS. It can send SMS to your mobile, an email to your email ID, something like that. And Glue can dump this data in S3. Okay, so that in future the engineer can come and investigate what is wrong with this data and how to fix it. And here you can have PySpark code, you can have Scala plus Spark code, you can have Java code. So you need to know something actually. Spark is, uh, Spark is something, it is on memory computation. Initially, what happens? It In earlier days when I started my career, it is like two-tier application, the client and server. Then comes the middleware, client, middleware, server, and everything. The data data would stay in some server. It fetches the data, do some calculation, and send back to another storage. So what Spark does, it takes the data itself in the memory. Okay, in the memory it takes it, and then on the memory itself it computes it, transforms the data, computes the data, and then in memory it does the calculation and sends it back to some other location. So that is the beauty of Spark. It is costly. You need to have enough memory, otherwise you need to lose your data. You will get some error like the memory is full, something like that. Memory means RAM, read on rapid access memory, I believe. I forgot all these names. So RAM, in RAM you're doing the calculation and it's very fast, just like your computer PC. Something is there. And say for example, in Spark it is lazy evaluation. Say for example, you are reading a book. Okay, now you have the book has 100 pages, and the thing is that like the book, and you are writing a program, and you can check, okay, how many times a particular word happens in 1 to 10 pages, not the entire pages. The thing is that there is a concept RDD, resilient distributed data. It does not do anything. Whenever you calls it, then only it goes and check for this book. Otherwise, it does not waste its memory by loading the book entirely in your memory. It is called lazy evaluation. It is a concept of RDD. So all these things I'll actually anyway, to keep it short. So the thing is that like here you have written some PySpark modules. It is in S3. It is in Glue schema registry. Glue takes the data, validates it. If there is an error, it dumps here, sends an SNS notification. And if it is valid in thing, then it sends it to an open search. Open search is another kind of a NoSQL database. It what is stable in our RDBMS, that is index here. So it does not it does not impose any particular data structure. And the thing is that like it provides some Kibana kind of live dashboard. You can monitor in real time, in real time, like what is happening with the data. It provides some graphs and all these things, pie chart graphs, red line, green line, all these things are there. You can join two tables over there, so everything is available in live dashboard. Now now think of it. I have mentioned the NRT streaming architecture, near real-time architecture. So every time if you push it to open search, it is an API, right? So in 1 second you may have 100 APIs. So it is very costly. So you need to have the cluster size of open search, or initially it was Elasticsearch. We used to say it ELK. It should have been, it should have been very huge. Now say in every 5 seconds, I don't mind. I can wait for 5 seconds to get the latest update. Okay. So in 5 seconds, there are 100 things are computed, and there is a concept of data frame. It is residing the data frame in the memory for 5 seconds, and in every 5 seconds, it sends data to this open search. And here, in every 5 seconds, your live dashboard is refreshed, and you can get the real insight of the data. Now, Here, now see, these are Redshift data warehouse. There are two different kind of databases or data mart, you can say. One is OLTP, online transaction processing, and one is OLAP, like online analysis processing. So what is OLTP? Like you withdraw $100 from your ATM, and there is a transaction ID, and you get it in your withdrawal slip. This is a transaction ID, and you have withdrawn $100. So that is thing. Now, say for example, your bank, say State Bank of India, you ask them, okay, what is my expenditure for this month? How much I have spent in fuel, how much I spent in shopping, all these things I need. Then if State Bank of India puts your data in Redshift, there you can run OLAP application, you can aggregate the data, you can generate a report, and it can mail you to your postal address to courier, and you can get the insight of your expenditure. That is called OLAP. So this kind of things. Like now, what is step function? Step function is nothing but it's an orchestration tool. It decides like, okay, for this step I need to run this step. If this step fails, then I need to go to this step. If not, then I need to go to that step. You can say that it's an orchestration tool, and say in every 4 hours. Now I don't mind, like in every 4 hours I need to run a batch. In every 4 hours, this step function can be, triggered by event also, by time also. Like in every 12 night, then 4 a.m., 8 a.m., 12 p.m., it gets triggered and it runs another glue job, and there is a config file. You can store it anywhere in S3 or anywhere, and it goes to this file and checks, okay, out of this, in which database I need to push the data. It may be RDS, it may be Redshift, Dynamo, and any other things, okay, through JDBC connection. It may be all of them, it may be one of them, it may be neither of them. So that part is done by this step function. Okay, clear? And again, there's a connector, it should have, say, in order to talk to RDS, you can say that here you can load, it's kind of an Oracle table. So in order to talk to Oracle, there should be a connector actually. So here you can, using that connector, it can load data to RDS table. Now there is a catch. There is a concept actually in real time, also in batch processing. That is called provisioned and serverless. Serverless server, it's kind of funny to understand. Glue is serverless. That means, say if something happens, then only Glue kicks off. Say data is very, say in every 4 hours, we get a single record. Then it is wise to deploy Glue because it is very cheap. So when it is done with this calculation, it stops and it saves your money, because AWS is not running any computation here. It is in idle state. It will be only activated by some trigger. So we deploy Glue as serverless. Okay. Now what is provision? Say your data is continuously coming here, continuously. You are watching the Sensex. Hope everybody is from India, like Bombay Stock Exchange. You need for I don't know, like maybe 10 a.m. I believe in the morning to 4 p.m. in the evening. You're watching the share market, the Sensex, how ups and downs, bear and the bull. So there, I suggest instead of Glue is costlier, cheaper because it is serverless. But I would suggest instead of Glue, there is a concept of EMR, Elastic Map Reduce. You can provision it and you can buy something. Okay, I need this much computation power. Okay, and I need to run it during from 10 a.m. to 4 p.m. or 5 p.m. So it will be continuously running, and you have provisioned it. That means it will be, if you compare the prices, then Glue will be costlier than EMR. Okay, and one thing you can notify, and this MSK server. If I go here, the Kafka cluster, I forgot to mention, there can be two types of cluster. One is, a standard cluster. Standard cluster means a standard broker, and one is express broker. So there are three kinds of, um, mm, uh, CPU can be provisioned. One is T3, T3, one M5, and one M7G. M7G is costly. So that is standard. Most of your work can be done with standard cluster. And if you want more very low latency, then you can go for express cluster. Okay. And that only M7G is supported by express cluster. Okay. So I think it is clear to everybody, and this is how it can be fit to any generic app. Say maybe you are in a factory, and all the machines are functioning, and you are consuming this data using Blue or EMR, and you are doing the analysis, and in live dashboard you can check the health of the machines. So if anything goes wrong, then it will be caught here, and the site engineers would rush to the place and fix it. Okay, so it can fit in anything. Like, it's a very generic. Now there is some injection mechanism. I just simply go through it. I don't want to go into details, like how to send messages. First one, there are some repetitions also for your understanding. So direct Kafka producer on IoT devices. Like, this is like, Raspberry is a hardware actually, and industrial grade, it's a hardware. It can run Kafka client directly on it. So what is Kafka client? That means the Python code. Python, Java, C++ written in client library. And this is MSK broker I have mentioned. And authentication is IAM is IAM authentication, SASL, Scrum is user ID password, and there is a concept of SSL. That means certificate based. I'm not going into the details. Another thing is that IoT Core. IoT Core is a service provided by AWS. And again, it can trigger Lambda, and that Lambda will act as a producer, and it can send data through MQTT. Message queuing, telemetry, process, something like that in MQTT. It's kind of an HTTP request. And that way you can send it to producer of MSK, and you can consume it from the consumer. An edge gateway. The green gas is again a software that can run on Raspberry, as mentioned here, and it is provided by AWS, and you can send messages to MQTT, and it can forward the message to MSK topic. See that here again, the green gas only, green gas, like it can run Lambda function local. Even if you are offline, you can run Lambda and store the data, and when you are online, you can send it directly to your broker. And you can, like REST proxy, everybody knows it, like get, put, host, get and post of it. Just, you can work in Postman kind of thing. So it can have some HTTP request, and it can send data to Kafka. Now, as your madam from your college says that the Gen AI or AI is the main thing. Like, so coupled with the streaming data with AI, you can do anything. You can go to your enemy country, bombard their military bases, and come back safely. And because of AI, like, it automatically detects actually where you are. So here another example you can think of, like, say for example, in India, road are in very jam packed during the office hours. So we can have real time data, like it can capture data, which road is congested, which road is less congested, which is maybe a shortcut, but it takes more time. You can go to an alternate route. So it will be faster. So everything, continuously it is monitoring everything. And there is something like, you have heard of Tesla, right? It is an AI driven car. So their real-time insight matters. Okay, so you don't have to have the driver. The car will drive you wherever you wish. You just need to give the destination, and according to some some signals, it will automatically pass through and take you safely to your destination. So there are so many things, like with real-time data analysis, you can be um, able to perform. Like say, for example, the crime rate, like say you are, say somebody is going in the wrong direction, though the road is one way, it can be caught. And there is, let's say, now say for a particular block of the city, say there are 100 traffic surgeons. Now, with the advent of this real-time analysis coupled with GenAI, only one sergeant can be deployed over there and 9 can be deployed where they are necessary. They need to do some manual work, something like that. So the crime rate will also be decreased and all these things. So these are some common things I have put forward. So um, I think I know like it is very short, but I'll pause, I'll stop here and I'll let you ask questions actually. So yeah, uh, so anybody like if you have any questions, so feel free to ask. I'll try to answer you as best as I can. Uh, yeah, anything. Yeah, I can see no questions. Maybe so. You can mail me. You can go to you can what I think you can go to Apache Kafka architecture that is available. You can Google it. Apache, what is Apache Kafka? Then you'll have the concept how Kafka works, and then in the Amazon document you can go how MSK comes in the feature. It is software as a service. No, nowadays nobody is building hardware. Like we lease it for 1 year, for 3 years, we lease it, and we don't want to buy anything more. The it's a huge paradigm shift. So that's all I have. So I have 10 minutes, and if you don't have any question, then I'll give you back 10 minutes.
Please contact us. यहाँ पे 2-3 मेल डालिए उन्होंने।
Sorry, I'm not able to hear you. Can you? There is some problem. Can you please write it in the chat so that I can in the common chat, because that there's so much and your voice is muffled. Yeah.
Jaydeep, Reshma here.
Yeah,
Yeah,
Reshma.
the diagram that you showed has step function also. So what is the use of step function in this architecture?
Step function, say for example, you are watching the Sensex, okay? Bombay Stock Exchange. Now, now in the live, you are getting the data live, right? You are watching it in your laptop. Now, at the end of the day, you want to, you have some software which will give you the insights, say how many shares you have bought or sold, okay? So that you need to do it at the end of the day, right? Because so in
Got
order
it.
to how much profit you have you reap or how much you lose, okay? So this step function is running a bad job, this bad job will do the calculation. So at the end of the day, you click the software, that means you are starting the step function, okay? And this step function triggers some arithmetic operation and give you the result. Okay, you are up by $100, you are down by $10, something like that.
Got it. Got it.
So if you go to Amazon document, you can search what is AWS step. See, there are two types of, say for example, okay, I need to see in a program, you are writing several modules, right? Say after completing module 1, module 2 should proceed, something like that, right? So in another thing, in distributed environment, we can see that, okay, the module 1 is running in machine A, module 2 will run in machine B or somewhere else. Then this step function will do the automation. Say, no, not automation, I'm sorry, the orchestration. Say after module 2 will only start when the module 1 finishes in success or in error. Something, some condition you can give. So there is another alternative also that is more robust, and that is Apache, that is called Airflow, Apache Airflow. Again, it has been, I think Amazon has taken it. So there you can write the, Python code, and you can clearly mention that it will be more generic. Apart from step, it is more robust. And if you know Python, it will be easy to pick you up. Then you can do the proper orchestration. Okay.
Okay,
So this step function is an orchestration tool provided by AWS.
got it, got it.
Okay, right. Yeah.
No, I
Anybody?
am aware of step function. I
Hmm.
was not able to understand why is that step function the in your architecture why it was
Hmm.
getting used there.
Say for example,
Got it now, yeah.
no, actually say for example, in every, say there are millions of messages in every 5 seconds, right? So can you trigger 1 million APIs to RDS database,
Absolutely not. No.
right? It will hang your system.
Yeah, yeah,
It is better to, at the end of the day, like in every 4 hours or in every day, I can dump the data at one shot in RDS, right? That
correct.
is better approach, right? So that's why it is not a part of real-time architecture.
Got it.
Okay, I wanted to share you what happens in real-time scenario. Like that, I wanted to convey to you. Okay, Rishma.
Yeah, thank you, Jed.
No issues. Yeah, I can see somebody has typed something. So, okay, I can give you back 6 minutes. Happy learning, AWS. Wish you all the best in your future endeavor. I'm May you be the all good architect in future India.
Uh,
Thank you. Yeah, yes, madam. Hima.
Now I request the vote of thanks is given by Suma ma'am.
Okay.
As the current section comes to close, I, Suma, team member of Academic and Industry Council of Computer Society of India, on behalf of Computer Society of India, would like to thank our excellent speaker of our webinar, Mr. Jaydeep Pal. Your
Thank
expertise
you.
has truly enriched our understanding. Jaydeep sir, on behalf of the entire team, I want to extend my sincere appreciation for your time and effort in presenting at our webinar, our data streaming using AWS Stack. Your expertise on the subject was evident and your presentation both informative and engaging. The feedback we have received has been overwhelmingly positive. Attendees particularly valued your clear explanation of complex topics and practical examples you provided. Your insights have undoubtedly given our team a deeper understanding of how to effectively implement data streaming solutions using the AWS stack. Thank you again for sharing your knowledge and making our event a success. We look forward to the possibility of collaborating with you again in the future. We are grateful to Capgemini India, a global leader in digital transformation, for supporting this initiative of bridging the gap between academia and industry with a special focus of knowledge increase of emerging technologies. We are grateful for Capgemini continuous support. We would like to express our sincere gratitude to GuruNanak Institutions of Technical Campus, an autonomous institute and one of the Telangana's most popular institutions, for our support to this webinar. We commend your dedication to fostering technical excellence and innovation through continuous programs in association with industry and the CSI. A huge thanks to GuruNanak Institutions of Technical Campus supporting this webinar. This is an honor to work with such a popular and forward-thinking institutions in Telangana. We really appreciate your ongoing efforts to connect students with the industry and CSI, as we thank them for their support. Special thanks to Kirti Madam and Sandeep Daskar Sir of Capgemini for your continuous help in conducting webinars. Finally, thank you to all the participants for your time and engagement. Let's continue building impactful user-focused solutions together. Hope to see you all in the upcoming sections as well. Thank you, sir.
I am honored. Thank you.